But so today we're going to be looking at completing the square. So a little bit of review, maybe from algebra and a little bit, see how much you remember from your factoring unit. But the one thing when we complete the square is we're going to get something called a perfect square trinomial. Basically, it's a trinomial. And if you don't know what a trinomial is, that's just an expression that has three pieces. Like we have an x squared part, an x part, and a constant part. But a perfect square trinomial is when you have the condition where, and this might seem a little bit strange, it's not that important, but b over 2 squared equals our a times c. So I don't remember how much you remember from factoring. We'll cover this a lot actually in our next section. So if this is something that's a little bit fuzzy, we'll work on it. But I don't know if you remember when you factored, why didn't it? Right. But when you like this first example, oh, why is it paused? Really. All right, so looking at this first example, sorry about that. If you remember how to factor, that's where, I don't know, like depending on your teacher, but you try and think of a number that multiplies the 16, your C, and adds up to your B. So if it's a perfect square trinomial, like what's the number that multiplies the 16 and adds up to 8? Well, it would be 4 and 4. So we could write this as x plus 4, x plus 4. But really, the easier way to write this is to just put x plus 4 squared, because that really means x plus 4 times x plus 4. So we're going to see when we're completing the square, it's always going to be a perfect square trinomial. It's always going to be the same factor. So like, for example, if you had a trinomial like this, what multiplies to 81 but adds up to negative 18? Well, that would be negative 9 and negative 9. So that would be m minus 9 squared. What about this third one? And if this is a little bit fuzzy, like I said, our next, like, well, Wednesday is the asynchronous day, but on probably Thursday, Friday, we'll be doing a ton of factor review. But what would this one factor into? What multiplies to our C or our 1 and would add up the 2? And I don't know if your teacher wrote it like that. Some teachers write it with like this x, like what multiplies to 1 and adds up to 2. I don't know if that looks more familiar, depending on your teacher. So some write it like what I have on the left. But what would this factor into? If you want to try this one, you can put it in the chat, or if you want to just write in. Wait a second. Where's the? Oh, okay. Yeah, and that is correct. So that would be, oops, a plus 1 squared. And hopefully, I mean, it might be really rusty because you obviously weren't factoring in geometry, but hopefully this like seems a little bit familiar. Like I kind of remember doing that. But if not, well, we will be doing a lot with it, like I said, in the next section. But when we're completing the square, we're going to see we end up with one of these perfect square trinomials, or basically it's always going to be like one of these simple ones. Like this one, since it's a minus 10, that would be negative 5 and negative 5. Multiplies to 25 and adds up to negative 10. But and if this is a little bit rusty, or you're like, I don't know what the heck just happened there, we'll see. It always kind of works the same way with these completing the square, and I'll kind of show you like a tip too when we're going through it. But that's really why what we're going to do when we're completing the square. Basically, we're going to try and make our equation turn into one of these perfect square trinomials. So we have to do a little bit of modification. But like I said, our goal today is to go from standard form to vertex form. Why, you might ask? Well, one, it's vertex form is usually easier to graph. The second reason is obviously vertex form makes it easier to find your vertex. So if you're not actually graphing to, like maybe you don't want to graph something in standard form, but you want to find the vertex. Well, if you convert it to vertex form by completing the square, you can pull out the vertex pretty easily. So we're going to see our steps are we group our ax squared plus bx part together. We just kind of look at the first two terms of our trinomial. We'll see if we have a coefficient, we have to factor it out. We'll see kind of how to deal with that. It does make it a little bit tougher. But we're going to complete the square by taking half of b and squaring it. So when you complete the square, and we'll see in our examples, but one thing you're going to do is you're going to take half of your b term and square it. That's kind of like if there's anything you're going to have to memorize or know in this process, it's b over 2 squared. We subtract it from the end of the equation. We'll see how that works. And then we're going to factor. So let's just jump into a problem, but these are the steps we're kind of following. So the first thing we want to do is group our first two terms. So I usually like to write it below. So I'm going to write x squared plus 4x. I'm going to leave a little bit of space, close my parentheses, and I just leave the plus 4 on the outside. So that's what I mean by group in the first step. So we're going to have to complete our square. Basically, we're going to try and make this a perfect square trinomial. So to do that, we're going to do this b over 2 squared. We can skip step 2 because we don't have a coefficient with our x squared. So to complete your square, you do b over 2 squared. You take this b term, which would, in this problem would be 4, cut it in half and square it. So 4 over 2 squared would really be, oh, what did I do? One sec, sorry. That would be 2 squared or 4. So whatever you get here, and I'm gonna change its color just so you see, like, I'm gonna make this in red. So when we do this completing the square process, and sorry, I'm just kind of doing that on the side, that's what you're going to put inside this parentheses. Here's the deal, though. If I add a plus 4 to this like expression or this equation, I can't just add it and not do anything in return. If you add a plus 4, well, we got to do the opposite to the outside of our parentheses. So I could subtract a 4 on the outside. So basically, I didn't change my equation. I added a 4 and I subtracted a 4, but in the end, we're the same. So now we're ready to factor this trinomial. So this, if you look here, this is going to be a perfect squared trinomial, like x squared plus 4x plus 4, like what multiplies to 4 and adds up to 4x, like you could just do x plus 2 squared. One tip, whatever you get inside your parentheses here, like whatever b over 2 is, that's what you're going to add or subtract inside your binomial, or like inside your parentheses here. This plus 4 and minus 4 just cancels out. So this would be our answer, like in vertex form. So if we wanted to know the vertex, well, our vertex would be, well, the h would be -2 because that's the opposite of what's inside here. And then our k, or the outside number, would really be a 0. So, and we're going to do a lot more problems. So like if you're still wrapping your head around it, I get it. It's a little bit strange at first, but that's completing the square. Basically, you group those first two terms. You figure out what would make it a perfect square trinomial. But whatever you add or subtract on the inside, you have to do the opposite on the outside. But then once you clean it up, you got it in vertex form. So it's pretty easy to pull out your vertex once you've got it here. But this process is called completing the square. So if your teacher ever is like, hey, we need to complete the square, this is the process they're talking about, this b over 2 squared. Okay, and I am recording. I just wanted to double check, so that's good. I didn't screw up today. All right, let's look at another problem. So the first thing we're going to do is group up our first two terms. So I like to write it below. And I leave a little bit of space for like whatever I'm going to add or subtract. And then I just write my constant on the outside, so plus 18. So this is where we need to complete our square. So that's b over 2 squared. This is what's going to let us get my perfect square trinomial. So I'm just going to kind of squeeze it here on the side. But b over 2, well, since it's minus 8, that would be negative 8 over 2 squared, or really negative 4 squared is 16. And it's always, I mean, it's always going to be a plus, because, I mean, anytime you square a number, it's always going to be positive. So it's always going to be plus something on the inside here. But remember, here, and I should use a different color. So this is, so if I add a 16, though, to my equation, I can't just add 16 for no reason. That changes the problem. You just can't change the problem just to make it easier. So if I add a 16 on the inside of these parentheses, I have to subtract a 16 on the outside. Like, basically, you got to make sure what you did was a net zero change. Like, I mean, so if you add 16, you got to subtract 16 to kind of fix what you changed in your problem. So now we can factor this. What would multiply to 16 and add up to negative 8? Or really, it would be x minus 4 squared. And then we can combine our constants. So 18 minus 16 would be positive 2. But one tip, one thing you're going to notice, whatever you get here is what you're going to have inside here. So if you're not super comfortable with factoring, like whatever you get when you do your b over 2, like inside your parentheses before you square it, that's what you're going to have in your vertex form. So our vertex, since they ask us to write it out, since it's in vertex form, it would be positive 4, positive 2. And that's completing the square in a nutshell. We're going to see in problems 3 and 4, it gets a little bit like when we deal with a coefficient, it changes things a little bit. We got to be a little bit more mindful about what we're doing. So just give me one sec. All right, oh no, my screen turned off. Okay, my screen turned on. It's a lot of tech issues today. All right, so let me know if you guys don't see me, but I think it's good. All right, so problem 3, we're gonna group up our a and our b part. But here's the deal: if we've got a coefficient with our x squared, we got to factor that out. So really, I'm going to rewrite it like this. I'm going to pull out a negative 1. So that would turn this to a positive x squared, which is what I want. I just want x squared by itself. But that plus 6x would actually turn into a minus 6x if I factored out a negative 1. And I'm just factoring it out of this first group. So like the minus 5, I don't change its sign. So if you have a coefficient, you want to factor it out of your group, or basically divide everything in your group by it to pull it out. Because if I multiplied everything in this group by negative 1, I'd be back to where I started. But other than that, right now it's the same process. We're going to complete the square. So negative b, or sorry, not negative b, b over 2 squared. So that would be negative 6 over 2 squared. If we work that out, that'd be negative 3 squared, or that would be 9. So I'm going to put a plus 9 here. All right, here's where things get a little bit tricky. So I wrote a plus 9, but if you really think about it, because I pulled out this negative 1, this is really a minus 9. Like, so even though I wrote a plus 9, really what I added to my equation was a minus 9, if you think about it. So to undo that or cancel it out, I'm actually going to add a 9 out here, because that would cancel out that plus 9 I put inside those parentheses. So I hope that makes sense, because that plus 9 is really a negative 9 if you distribute that negative 1. So the opposite would be a plus 9. So that's a lot of times where we get kind of messed up with these. But I mean, other than this, then it's the same idea. We can factor this. So just bring down that -1. But this would be x minus 3 squared, because -3 times -3 is 9. -3 plus -3 is -6x. Or like I said, it's whatever you get inside here is basically what you'll put in your binomial. And then -5 plus 9 would be +4. So my vertex would be +3, +4. All right, I'm going to do one more, like of these ones with a coefficient. And then I think maybe to kind of wrap up today, I'm going to have you maybe try some of these on the back side, just to kind of see how we're doing. And then we'll work on this some more tomorrow. We'll have some kind of assignment or practice this some more in class tomorrow. So disregard what I said about the delta math. Maybe we'll do that tomorrow. I don't know. All right, so same idea. You're going to group up your first two terms, but we don't want a coefficient. So I got to pull out this 2. So if I pull out a 2, this would be an x squared. Basically, I'm going to divide everything by 2 inside the parentheses. So that would turn into a -6x. Leave a little bit of space. Because basically, if I distributed, that would take me back to where I started. We're basically pulling out a GCF. So if we complete our square, this is actually the same as last time. It'd be -6 over 2 squared. That would be -3. That would be 9. So I'm going to put a +9 inside. But remember, if I distribute this 2, that's really an 18. So I really didn't add a 9. I added an 18. So to cancel that out, I would subtract 18 on the outside. So if you have a coefficient, just be careful. It changes this step here where you got to like undo what you add or like what you put in your equation. But I mean, other than that, I mean, this would still factor out simply. This was actually the same trinomial we had in the last problem. So this would be x minus 3 squared. 13 minus 18 is -5. So my vertex would be 3, -5. So just to kind of reiterate, like all we're doing is like completing the square. It lets us take something that's in standard form, so like ax squared plus bx plus c, and turn it into vertex form, like a parentheses x minus h squared plus k. Like, so we're converting the forms. So what I'd like you guys to try